Hey, welcome back, everybody. It's Mr. A here. Today we're in section 10.2. We're going to be talking some more about circles, and specifically today talking about measuring angles and arcs in circles. All right, so our objectives: identify central angles, major arcs, minor arcs, and semicircles, and find their measures. And then find arc lengths. Okay, so first of all, a central angle of a circle is an angle with a vertex in the center of the circle. So hopefully I've got an example here that I can show you. And so here in the circle, the central angle is from, remember last time we talked about the radius, you had the center, from the center to the outside edge, that was the radius. Well, basically, if you have, I guess the way you can think about this is if you have two radii, then they will form a central angle, okay? So, for example, here, angle 1 is a central angle. It's this angle right in here. Angle 2 is this angle right in here. So it's an angle from the edge of the circle, and the vertex goes to the vertex is where the angle is formed there, okay? All right, so, oh, by the way, too, the other thing that's really important to notice here is that in a circle, all of these angles, angle 1, angle 2, and angle 3, all together, they will add up to be 360, okay? All right, so let's do an example here. We're going to find the value of x. Okay, so in our example here, you notice we've got some things drawn. We're trying to find x. Come on, pen, where are you? There we are. So we're trying to find this right here. All right, so we know that there's a total of 360 degrees all together in this the central angles of this circle. And so hopefully I've got it worked out this time. Yes, there we go. And so what I can do is I know if there's 360 degrees total, this is a right angle, so it's 90 degrees. All I have to do is take 360, subtract the 90, that's this one, subtract the 40, and then subtract the 85. And so if I just subtract all of those from 360, what I'm left with is 145 degrees, okay? So in this case, x would equal 145 degrees. Okay, pretty easy, right? So the main thing is remember 360 degrees there in a circle. All right, ooh, a little bit more complicated. But let's kind of think along the same lines here. We're trying to find x, and probably what would have been more fun is to like find the measure of one of the angles, but that's the way it goes. All right, so what we can do here is we can, if you look at that circle, I think probably the easiest way to go about this is if you look at that here, that RV looks like a diameter there. Okay, and so if there are 360 degrees total in a circle, and half of that circle, there would be 180, right? And so what we could do is, if you notice here, this angle, RTS right here, STU right here, and UTV right here, those three angles should all add up to be 180. So what we can do here is this, we can say 8x minus 4 plus 13x minus 3 plus 5x plus 5 would need to equal 180. Okay? And so we'll just use some algebra here to put these together. So we got 13x, 5x, and 8x. And so altogether that's what, 26x it looks like. And then we've got 5 minus 3 is 2. 2 minus 4, it looks like, is a negative 2. And then we'll go plus 2 So 26x equals 182, and then divide by 26. And so 182 divided by 26. And so it looks like there that we have x is 7. So that's what they were asking for, so x is 7. It would have been more fun that if we were trying to find the angle of RTS and we just plug 7 in here and work it out, but I think you can do that. All right, so but the whole point there is that you have 360 degrees in the circle, and if it's in half the circle, you have 180 degrees there. Okay. Now, the next step with all this is we've been talking about central angles. Okay, and so in this situation, we're going to start talking about arcs. All right, so an arc is a portion of the circle defined by two endpoints. All right, so what that means here is, like if we took, we'll talk about these here in a second here, but look at this diagram here. If you take this point from A all the way on the edge of the circle to B, that is the arc, okay? So the arc is the actual like curved portion, the outside curved portion of the circle. Now, what happens is the reason why we talked about central angles first is because if you notice here that in this case I'm talking about here from center C, this is a central angle, like this x degrees here. So we make this central angle, and that forms arc AB. Okay, and so the first thing that's kind of interesting here is, well, let's talk about the arcs first. First of all, a minor arc. Okay, so a minor arc is less than 180. All right, so remember 180, like we just did in that last example, is straight across. If you have a straight line straight through the diameter there, that's 180 degrees. So this is less than that. That would be a minor arc. Okay, and now the other thing to keep in mind here is, in this situation, the central angle, if that's x degrees, then the arc AB would also be x degrees. All right, so the central angle and the measurement of the arc, it's the same number of degrees. Now, if you hadn't noticed already, if you look over here, see this little curved line over the AB? That's the symbol that shows that it's arc AB, not line segment AB or anything else, but the little curved line means it's arc AB. So again, the M, that's the measure of arc AB. So the measure of arc AB would be in degrees, and it would be exactly the same as the degrees of the central angle, okay? Then next we have a major arc, which you go, oh, well, that would be probably the any arc that's longer or greater than 180. And so if you notice here, we're talking about this red arc here from A to D all around to B. That whole thing, that's a major arc. It's bigger than 180. Now, we have to name these slightly differently here. If you notice on the first one with the minor arc, we named it arc AB. It went from A to B, from one endpoint to the other. Here, you notice this arc goes from A to B as well, but we can't call it arc AB because that would mean it's the same as this. So we have to call it using A and B, but then we have to use one other point in the middle here. So if it's a major arc, we cannot call it AB. If you want to mean this arc here, you have to use one other point out here. So you go from A to D to B. And so the measure of arc ADB would mean this major arc here. Okay, if you just say AB, it's the short or the minor arc. Okay, and then finally, semicircle is just 180 degrees. It's exactly 180 degrees, and so there, in this case, they called it ADB. You know, it should be this side. I don't know. Probably since it's exactly 180, I don't know if you'd need to call it ADB or if you could just call it AB, because either way, it's going to be 180 degrees. But semicircle is 180, major arc is bigger than 180, minor arc is less than 180. All right, we're going to classify a few things here. So WC, here's WC, it's a radius. And then we want to call arc XZY. We want to say, is it major, minor, or semicircle? So X, where's X? Here's X, and then Z to Y, XZY. We want to figure out, is that a major arc, a minor arc, or a semicircle? If you look at that, you go, well, what does that have to be? It looks like line XY here is a straight line. That's the diameter. And so, what would we have to call this here? Well, that would leave us with 180 degrees or a semicircle. Oops. There we go. You get the idea. Okay, and so a semicircle is always 180 degrees. I feel like I'm getting really sloppy in my writing there. Okay. Next. Say same stuff here, but we're looking now for WZX. Okay, so W, from W to Z. Oh, now, well, actually, look, it's going from WX, ending at X, so it's going from here, this W around this way to Z to X. So we're talking about all of this, that arc there. So from here all the way around is what we're talking about. So that's a major arc, right? It's much bigger. And so how many degrees would that be? Well, if you notice, I mean, you could think about this a couple of different ways, but if you notice, this is labeled as 90 degrees here. And so how many degrees are there total in a circle? There's 360. So you could just do 360 minus 90, and that would give you 270. So this would be 270 degrees. The other way you could have done it is you could have said, oh, half a semicircle is 180 and then another 90, and that would give you 270. You could have thought of it that way too. All right, and then one more here, XW. So here we got XW is this one. You go, well, that looks like it's 90 degrees, and so that's got to be less than 180, so that's a minor arc. And again, it's labeled as a right angle, so that means it's 90 degrees. Okay. All right, congruent arcs. In the same circle or in congruent circles, two minor arcs are congruent if their central angles are congruent. So remember before we just said the central angle is the same as the degree for the arc. So if you have two central angles that are the same amount of degrees, then their arcs are also going to be congruent as well. All right. Let's find arc measures in circle graphs. Okay, so in this case now, we're given a pie chart here, or a circle graph, as you might say, and we want to find the measure of KL. Okay, so let's find where that is. Well, here's KL. So this is what we're trying to find right here. This arc. Now we can't. Now you might be tempted. Here's the thing that's tempting: is you might say, "Oh, well, we've been talking about the central angles are the same as the arc measurements. Hey, this is 21, so that'd be 21. Remember, this is not 21 degrees here, though. This is 21%. Okay, so we have to treat this a little bit differently. All right, so what we need to do here is we need to find the degree. Really, we can find the degree of the central angle. It's going to be the same as the arc. Well, how many degrees do we have total in a circle? 360, right? So we have 360 degrees. And this, in this pie chart here, the part that we're trying to find is 21%. So if there are 360 degrees, our part that we're trying to find is 21% of 360. And so we're going to take this 360 and multiply it by the decimal form of 21%. Remember, which is 0.21. Remember, if you have 21%, you can just move the decimal 2 places to the left to make it the decimal point 2 places to the left to make it a decimal, and then multiply. So we're just going to go here 360 times 0.21. And so then it looks like there that 21% of 360 would be 75.6. And so that's the number of degrees. And so we are 75.6 degrees. Okay, so we could do the same thing for any of these other ones. If we wanted to find JK, we just take 360 times 0.37, and that would tell us how many degrees. So times 0.26 would tell us this one, times 0.09 would give us that one, and times 0.07 would give us that one. So whatever we need to do, we just take the decimal form of that percentage times 360 would tell us how many degrees. And now in this one, now if you notice here, it said find the measure of arc NJL. So from N to J to L. Okay, so that's all this together. Okay, well, you could do one of two things. You could do what we did before and find each one individually and just add those up. Or we could just add the percentages first and then multiply. And so let's do the percentages first. So I'm just going to do this. I'm going to go 26 plus 37 plus 21. And so it looks like that's going to give us 2, 4, 5, 6, 7, 84. Is that right? So 84%. So the part that we want to find is 84%. So now to find how many degrees that would be, since there are a total of 360 degrees, we just go times 0.84. And so, and then we just go 360 times 0.84. And so it looks like in this case that would be 302.4. 302.4 degrees. Okay. All right, arc addition postulate. This just means, we're talking about two arcs here. This just means that if you had this arc XY, the measure of that, and then if you added to the measure of YZ, it would you could just add those together to get the measure of arc XYZ, the whole thing. Okay, it's pretty straightforward, so I don't think I have to go into a whole lot of that. Let's just look at an example here. We want to find the measure of IJK. All right, so we want to find the measure from I to J to K. So we want to find this arc out here, which is a combination of two different arcs. It's a combination of IJ and JK. So we know, let's just do this. Let's write this in here. This one is 90 degrees on the central angle, so we know that the arc is going to be 90 degrees, right? So all we have to do to find IJK is if we can find JK here, then we can just add these two together. Well, okay, how might we be able to do that? Well, you could do this a few different ways, perhaps, but one easy way might be this. If you know that this is 90 degrees here, well, and here's a straight line, a diameter, that means that this side here, IH and HL together, would have to be 90, right? And so one way so what I could do here is I'm kind of going about this kind of through a back door here, is I could take 90 and subtract 32, okay? So if I just go 90 minus 32, I'm going to get what? 58, right? So why is that important, or why did I do that? Well, that told me what this angle is right here. Because together, 58 and 32 would have to be 90. Well, remember way back in the beginning of the year, we talked about vertical angles. Remember that? So HK and LJ are straight lines. They make vertical angles. So if this is 58, this would also have to be 58 central angle, which means the arc would be 58 degrees out here. And then I can just add the 90 degrees plus 58, and that gives me 148 degrees. Okay, so that's the measure of IJK, the arc IJK. Now, you probably could have done a few other things here too. I kind of showed you that way just to remind you about vertical angles or something that you could look for. Another way that you could have done this is, since you see that HK here is a diameter, and that makes 180 degrees, and so you could have also just done 180 minus this 90 minus that 32, and that would give you 58 as well. So that's another way you could have done that also. All right, now this, in the whole section, this is probably the hardest thing, the arc length. Okay, so when we talk, this is very important here, the arc length. We are no longer talking about the measure, the degrees of the arc. We're talking about the actual length of the arc, not the degrees of the arc. Okay, they're different. And so if you notice here on this diagram, here's the length, here's the arc, is this red area here, and we've put a little L out here. That's the arc length, not degrees, but it's the length. Okay, so if you put a ruler up on it, you could measure how far that is. Here's the thing is, remember, there are 360 degrees in a circle. And remember that the degree for the arc is the same as the central angle degrees. So what I kind of prefer, and actually I like it slightly different than this, I like to set up the proportion. And so what you do is you're going to take the length of the arc over the entire length of the circle. Okay, so the length of the arc is just this distance, and I'm going to make a proportion. So I'm going to say that the part of that length of the arc divided by the whole entire length of the circle. Well, what's the whole entire length of the circle? The whole entire length of the circle is the circumference, which is, I like to think of it as pi times diameter. Okay, so it's the length of your arc over the circumference, which is pi times diameter. They've got 2 pi r written over here. That will equal the degree of your arc, which is the same as this one here. So x over 360, because there are a total of 360 degrees in that circle. So kind of the way you do it here is like on the proportion, the top part is the part, so it's the length, the small part over the total, and then the part of the degrees over the total degrees. Okay, so that's why I like to think of it this way as a proportion. What they've got here is they've just gone ahead and then to get length by itself, they just multiplied by 2 pi r to get this equation. If you want to remember this equation, that's fine. Like I said, to me it just makes sense to go the part divided by the total, part divided by the total, and then solve it from there. So let's see what we can do with an example or two here really quickly. All right, find the length of DA. All right, here's DA is what we're trying to find, and so that's our L there, right? There's DA. And so I'm going to set up this proportion for the length of DA over, remember the total length is the circumference, or pi times diameter. I'm going to leave a spot here because, well, what's the diameter? That's what we have to figure out. A to B is 6. That's the radius. So the total diameter would be what? 6 plus 6 is 12. And that will equal the degree. So remember, 140 degrees, that's the same as out here. So this would be 140 degrees over 360. Okay, so we just set the proportion of the length over the total length, which is circumference, degrees, the part over the total. Now you could from here cross multiply like we've done before, but in this case, since we will always have just L on the top, it might be easier I don't know if I've left myself enough room here, but I'm just going to multiply by 12 pi. So that 12 pi will cross out that 12 pi, and then I can go times 12 pi here. That's where the formula comes in from before. And so, but to me, it's harder to remember that than just to go times 12 pi. So this, all I have to do is just type this into my calculator. And so I'm going to do here 140. Where's my, there it is. 140 divided by 360, and then I'm just going to go times 12 pi. And so it looks like okay, let me just get rid of that. Actually, no, I can't remember what the number was. I don't know what's going on here. This calculator doesn't like me today. All right, so we're just going to round that to the nearest hundredth, so 14.66 there. All right, so 14.66 centimeters. Okay, let's look at one more because that one's a little difficult, so I want to do another one here. So same thing, we're going to find the length of dA, so it's the same one here, L, rounded to the nearest hundredth. So let's set up our equation again. It's going to be the length divided by the total length. So that's circumference, or pi. Let me do it this way. Ooh, that's a pi. It's the circumference, which is pi times diameter. And so again, the diameter is going to be 6 plus 6, or 12. And then it's going to be, oh, now what happens here? We don't know what the degree is here. So what do we have to do? We know this is 28, so we can do 180 minus 28, right? So we're just going to go 180 minus 28. So we got 152 there. And so then here we're going to say 152 degrees over 360. Okay? So the part that we want to find, the arc over the total, the circumference, which is pi times diameter, the degrees over the degrees. Then I'm going to go times 12 pi times 12 pi so that these cancel. And then I'm going to type this into my calculator. And so I'm just going to go 152 divided by 360. And then times 12 pi. That's not pi. There it is. Nope, that's not it. Oh, when I went back, I had to re-hit the second function button. There we go, 12 pi. And so again, nearest hundredth, so that's going to be 15.92. And centimeters. Okay, well, there you go. There's section 10 too, dealing with arcs and lengths of arcs. So appreciate you being here. Mr. Anderson signing off, saying see you next time in section 10.3. Bye.